Hi guys, let us discuss assignment problem using branch and bound algorithm. Problem statement of assignment problem. Problem of assigning n people to n jobs so that the total cost of the assignment is as small as possible. In the problem, the data is given as a table as shown in this diagram. So in this example, 4 persons and 4 jobs. Each person and for each job, the cost is given in the grids. For example, if we take person A and job 1, the cost is 9. So what is this cost? This cost may be time or money or whatever it is. For example, if we take person B and job 2, the cost is 4. So like that, for each person, for each job, the cost is given in that particular rows and a column. Now we have to find the solution such a way that each person is assigned with only one job and the total cost is minimum as much as possible. Let us try to find the solution using branch and bound algorithm. Here we want to find the minimum total cost. So we use the term lower bound. So initially this is the start node and lower bound value is equal to, in each row you take the minimum value. Suppose for the first row, that is person A, we take the minimum value 2 and person B minimum value 3 and person C in this row the minimum value is 1 and person D in this minimum value is 4. So you add these values, 2 plus 3 plus 1 plus 4, total cost is 10. Here you may have a doubt how we can assign B and C with the third job. That is minimum occurs here for B and also for C also minimum occurs here. Let us not worry about that now. That is the minimum total cost, that is lower bound value is equal to 10 at the starting node. Strictly speaking, this is not possible at all because as per the problem we have to assign only one job to one person. So assigning job 3 to B and again assigning job 3 to C is not possible at all. But as we continue the process, we will get the correct solution. So now you take the lower bound value as 10. The first possible option is assigning job 1 to A. So when you assign job 1 to person A, the cost is 9. So in the lower bound calculation, use the value 9 here. And also you refer the table, the first row and the first column is shown in red. That means for other persons, you don't use this first row and first column. So for B, you take the minimum of other values, that is 3 here. For C, minimum of the other values other than red, so 1. For D, the minimum value is 4 here, so you add these values, 9 plus 3 plus 1 plus 4 is equal to 17. The next possible option is person A may be assigned with the job 2. So when you assign job 2 to person A, the cost is 2. So use this value 2 here in the calculation of lower bound. As we already discussed, now you refer the table, first row and second column is shown in red. That means these values should not be used for calculation of for other persons. So for B, you take the minimum value in this row 3. For C, you take the minimum value in this row 1. For D, you take the minimum values in this row 4, but you should not use the values shown in red. So again the calculation will be 2 plus 3 plus 1 plus 4, lower bound value is equal to 10. Now the third choice for person A is person A may be assigned with the job 3. So when you assign job 3 to person A, the cost is 7. So use this value 7 in lower bound calculation. And now the first row and third column is shown in red. That means these values should not be used for calculation of other persons. So for person B, other than the red value, so what is the minimum? 4. So use the value 4. For person C, other than the red value, what is the minimum? 5. Use the value 5 here. And for D, other than the red, the minimum value is 4. So if you add these values, you will get the lower bound value 20. The last option for person A is person A may be assigned with the job 4. So when you assign person A with the job 4, the cost is 8. So this value 8 is used in lower bound calculation. And the first row and the last column is shown in red. That means these values, that is the values in first row and last column, should not be used for calculation of other persons. So now you refer the person B, the minimum value other than red is 3. So use it as it is. And for C, the minimum value other than red is 1. And for D, the minimum value other than red value is 6. So use this value here, and total lower bound value is 18. We have explored all the 4 choices for person A. That means person A with job 1, person A with job 2, person A with job 3, and person A with job 4. Out of these 4, we are getting minimum lower bound value 10 when you assign job 2 to A. So let us expand only this node, because this is the node which gives me minimum lower bound value. When you expand this node, next the person is B. So person B may be assigned with 3 choices: B with job 1, B with job 3, and B with job 4, because we have already fixed job 2 to A, because this is the node we are getting lower bound value. So let us do it one by one. Let us do the calculation of lower bound value for this node. Now job 2 to A, it is already fixed. So what is the cost value for job 2 to A? 2. So I am using 2 in the lower bound calculation for person A. Now I am trying person B with job 1. So when you assign job 1 to person B, the cost is 6. So that 6 I am using it here. And also you refer the table. As we assign job 2 to A, first row and second column is shown in red. Like that, for person B is assigned with job 1. So the second row and first column is also shown in red. That means the values shown in red should not be used for calculation of other persons. So for person C, what is the minimum value other than red? 1. And person D, what is the minimum value other than the value shown in red? 4. So you substitute the values here: 2, 6, 1, 4. So you add it: 2 plus 6, 8, 9, 13. So this is the lower bound value. The next option for person B, the person B may be assigned with job 3, because we already assigned job 2 to A. So that is fixed. So 2 is used here for person A in this calculation. Now assign job 3 to person B, the cost is 3. So that cost 3 is substituted here, and you refer the table. As we assign job 2 to A, first row and second column is shown in red, and assign job 3 to person B, so second row and third column is shown in red. So for other calculations for C and D, don't use the values shown in red. So for C, what is the minimum value other than the values shown in red? 5. For D, what is the minimum value other than the value shown in red? 4. So substitute the values here. So the lower bound value is 14. The last option for person B, the person B may be assigned with the job 4. So job 2 to person A is fixed. So we are using the value 2 in this calculation for lower bound. When you assign job 4 to person B, the cost is 7. So that 7 is substituted here, and also you refer the table. So as we assign job 2 to A, first row and second column is shown in red. And we assign job 4 to person B, so second row and last column is shown in red. So for other calculation, we should not use the values shown in red. So for person C, other than the red, the minimum value is 1. And for person D, other than the red, the minimum value is 7. So substitute the values here. The lower bound value is 17. We have explored all the possible options for person B. Person B assigned with job 1, person B assigned with job 3, person B assigned with job 4. So out of these three, we are getting minimum lower bound value 13 when you assign job 1 to person B. So now we are going to expand only this node further. So when you expand this node further, already job 2 to A is fixed, job 1 to person B is fixed. So what are the other two jobs left? Job 3 and job 4. Persons are person C and person D. So now the next level options are person 3 may be assigned with the job 3, person D may be assigned with the job 4. The next option is person C may be assigned with the job 4 and person D may be assigned with the job 3. So now let us continue. The calculation for this node job 2 to A, which is already fixed, the cost is 2, and job 1 to B is already fixed, the cost is 6. When you assign job 3 to C, the cost is 1. When you assign job 4 to D, the cost is 4. The total cost is 13 here. The last option is C may be assigned with the job 4 and D may be assigned with the job 3. Job 2 to A is already fixed, the cost is 2. Job 1 to B is also fixed, the cost is 6. When you assign job 4 to C, the cost is 8, and job 3 to D, the cost is 9. The total cost is 25 here. Let us stop the process because we have assigned 4 jobs to 4 persons. Now the lowest cost 13 we are getting in this node. So the final solution will be job 2 to A, job 1 to B, job 3 to C and job 4 to D, because this gives me higher value compared to this value. So this is the solution for this problem. The final solution is job 2 to person A, job 1 to person B, job 3 to person C and job 4 to person D, and the total cost is 13. Let us solve this assignment problem using branch and bound algorithm.